Yeah, so I think the reason why we're all here is obviously to discuss the role of large language models in security testing. So again, thank you all for joining. It's good to see so many of you here. My name is Richard. I am the security engineer here at Cytix. My role here is to help build and deliver the internal security testing program we do, and also take part in some penetration testing and manual testing as well.
And I'm Thomas. I'm one of the co-founders here at Cytix. Yeah, really looking forward to kicking off the inaugural Cytix webinar series. So coming up, first of all, the key areas that we're going to cover are what our current development processes are, like how we actually go about delivering software, getting it into production, how we leverage some of the traditional security testing capabilities and talking a little bit about their uses and their limitations, and then why and when we use large language models to supplement this. Culminating in us giving you a little bit of a story about an interesting instance that we had recently where we actually introduced a vulnerability in our own application that wasn't caught through any of the different gates that we have and was only picked up thanks to the power of language models.
Yeah, and just before we dive right into things, there'll be time for questions at the end, but if you guys have any questions as we're going through, just please feel free to put them in the chat and we will get back to you when we can. So without further ado, I think a good place to start might be talking a little bit about our software development process itself and just sort of getting a little bit deeper into that. So I think one of the main, so do you have the diagram, by the way, Serena?
Yeah, just let you know, as we glance over in the background, our wonderful marketing manager is sat there behind the scenes working hard and getting all of these slides together. This is very much our first webinar run, so there are maybe a couple of teething issues as we go through. Yeah, so let's just jump into this then, start talking about our software development lifecycle. I think is a good place to start. You know, there are different ways that different organizations do things, but I think we follow quite a traditional path in terms of getting testing performed and getting changes deployed, with the exception of what we're doing around language models. And I think it is important to recognize the value that is being provided and the capabilities that are being provided through a bunch of different tools, most of which are free, by the way, and then to touch on why it is that we maybe need to extend a little bit beyond those. So yeah, I mean, you can see on the screen, this is effectively what happens every time a pull request gets raised, right? You get a series of different gates that have to be passed through in order for a release to be able to make its way to production. First one being static, software composition analysis, effectively just looking at the libraries that are being utilized, making sure that we're not effectively depending on any code that has known vulnerabilities within it, right? It happens all the time. It's one of the biggest pet peeves I think we probably both have as testers, right? Is you're testing something and you want to be finding new and novel vulnerabilities, but a lot of the time what you're actually doing is picking up that somebody's version of jQuery or Vue or whatever else it is legacy and needs simply updating. The next one is linting, not necessarily security related specifically. There are a couple of security specific linting rules in there. Really, it's more about code formatting and just making it as readable as possible so that everybody, developers and testers, can both understand what's going on, understand what the code's supposed to do, make sure it's in a consistent format and help along. Rich, do you want to touch on the other three key gates in there?
Yeah, sure. So we also deploy SAST towards the end of the pipeline as well, picking up on sort of some of the weaknesses that might exist within the actual code itself. We also perform DAS scanning alongside that, where, like you said before, can help pick up a lot of the other sort of low-hanging fruit vulnerabilities that in a manual test you might not necessarily want to spend so much time trying to identify those sort of low-hanging fruit issues and trying to write them up. So using tools like DAS scanners can help us, really speed up that process. But I think also importantly, we also do quite a lot of manual testing for those complex issues. And this is something that we found that large language models can be somewhat useful in helping us sort of figure out the context of what has changed as part of the latest cycle of changes. So traditionally, you'd get a pull request that might be raised by a developer, and this will contain a number of commits. It will contain a description of that change. And it's quite common in large sprint cycles to see quite a large number of these changes come through. And as a manual tester, it's really important to sort of, we talk about it a lot anyway, understanding the context around what we're testing so we can do better testing. And I think one of the main benefits that we found using large language models to help us build a sort of scope of work to carry out this testing is in actually reasoning about what kind of vulnerabilities this change could introduce, but perhaps more importantly, whether this is a testable change. And when I say testable change, what I really mean is whether it requires manual testing or just purely automated testing. So is it a change that could, perhaps likely just introduce a low-hanging, vulnerability, for example, missing HTTP security headers or something along those lines? Or is it a more complex vulnerability that might require a manual test to dig a lot deeper into that process? And that's where, in our software development process, we would deploy large language models to sort of help us reason about whether manual testing is required, and also more specifically, what type of manual testing is required and what types of vulnerabilities could be recovered. I think that's a pretty fair.
Yeah, but just going back specifically to the precursor to language models, I think so obviously we've got software composition analysis. We're looking for libraries and known vulnerabilities in publicly disclosed vulnerabilities in known pieces of software. We've got linting, which is really just about structuring and formatting and making things as clear as possible. Smoke tests are actually our way of defining out typical behaviors of the system. So effectively, all we're really doing here is saying there are certain things that should be reachable by certain users. There are certain things that shouldn't be reachable by certain users. And all those are some really, really simple tests to get run for every single piece of code to make sure that a user can't, for instance, access a different company's information, and make sure that a user can access their own information, right? SAST is probably the first point at which we're really doing some genuine vulnerability detection. And it's really, really good at finding certain vulnerabilities, especially things like injection flaws, right? SAST is really good at being able to read line by line code and understand where we are failing to sanitize input. It's really, really good at catching cross-site scripting. It's really, really good at identifying where we're not using stored procedures or structured queries to make SQL requests, and sort of doing that sort of line-by-line signature check for common code deficiencies. Then we've got DAST, right? DAST is another gate that you touched on, which is good at finding more dynamic vulnerabilities. So that's once the application's been deployed in a little sandboxed environment, running that, again, it's still kind of looking for signatures, but it's interacting with all of the different software components working together, right? Which means that it's able to find things, not necessarily better than SAST, although it can find some vulnerabilities that SAST isn't as good at, but it's able to find things with a greater level of confidence. Mm-hmm. If it is actually exploitable, DAST is more likely to be able to determine that is so. But there are vulnerabilities that SAST and DAST and smoke tests and linting are not so great at finding. For example, business logic flaws, right? A business logic flaw is effectively not a deficiency in the code, so to speak. A business logic flaw, you can write a piece of code and it does exactly what you intended it to do. But the problem comes when it does something that the business doesn't want to occur. A classic example is you are ordering from a system, right? You are going through a checkout process, and let's say you bought 1,000 phone covers from Amazon, Right at the very end, instead of that 1,000, you request minus 1,000. In principle, the system is doing exactly what it's supposed to be doing, right? You click order on that, and let's say you're refunded the money. The system is doing what it's supposed to be doing. It's looking at what the cost of the good is, and it's looking at the amount of the good that is being requested is. If it's a positive number, then it'll times it by whatever that number is. And if it's a negative number, then it will deduct whatever that number is, or in this case, it will refund whatever that number is. And those kinds of things, the code is fundamentally doing the right thing. It is taking that number and it is doing that math. But the impact to the company, because we understand that the company should never be refunding, right? The impact to that company is the negative thing. And neither DAST nor SAST are particularly brilliant at finding those kinds of vulnerabilities, because neither SAST nor DAST understands what the company is trying to accomplish. Which is really, really interesting, because people, you and I, all of the people who are tuned in right now would be able to say with confidence, you don't need to be a security expert to be able to say that's a bad thing in the system, right? But because we've not got the automation to do it, we need a human in that loop, which is challenging, right? That's I think it's probably worth drilling down a little bit into some of those challenges, and why having a human in the loop for every change is not necessarily something that, when we first set out as a business, wasn't necessarily something that was realistic, but it's becoming more so now.
And I think just on those more complex issues as well, it's just naturally when you have tools like DAST and SAST there, well, especially with DAST, you're sort of touching the edges of the application that you're testing, and it's able to pick up vulnerabilities that, like I've said before, kind of low-hanging fruit that are more complex. But a lot of the time, these really high-level issues are actually residing quite deeply within the application itself. There's quite a few levels that you have to go through to get to that point. And on your point about business logic flaws, again, these are things that something like a DAST scanner, like you said, is more heuristic based. It's not able to pick up on those more complex problems because those things aren't in place. And similarly, we talk about like privilege escalation issues as well, which again are quite serious vulnerabilities, allowing you to access stuff that you shouldn't be able to have access to. And I think just getting onto the point about where LLMs can sort of fit into that process. So if we think about the idea of when a change comes into our hands, and we're sort of deciding, on top of all of the other changes that we need to test within that period, does this one require our effort, a lot more time and effort to sort of dive deeper, and could this potentially introduce those more complex issues like business logic flaws, privilege escalation issues, or is it something that a tool like a DAST scanner could be able to handle, with ease? Is it, or something like a SAST would be able to pick up in a matter of minutes, and we could go through those? And I think where LLMs can sort of help in that process is that initial reasoning step. It's sort of saying, okay, well, based on the description that the developer has made, based on the commits that they've added and the pull requests and the code that they've actually uploaded, is this change likely to need security testing anyway? Or, and more specifically, if it does, what types of vulnerabilities could that change introduce? And this is where sort of business logic flaws and privilege escalation vectors are kind of highlighted to us, and we can really start to focus on, okay, well, maybe we should look at these changes first, and we should give these a higher priority. And the more lower priority ones, like, you might have some injection. Well, injection isn't necessarily low priority, but stuff that could be picked up by a DAST scanner or a SAST scanner quite easily can just be said, well, we'll offshore that to those tools. And obviously, there's a degree of false positives that come up when we use those tools. But again, it's just a case of going back to those and verifying that they are actually legitimate issues. But I think maybe it might be a good time to talk about the case study that we found. Or?
Yeah, just before that, I think what's really important in what you said there is, we're not proposing that you use LLMs in order to actually perform the testing. Right? I would love to say that there is a scanner right now that can find business logic flaws. That, as far as I'm aware, and feel free, audience, to correct me if I'm wrong, that isn't where we stand at the moment. We can't use automation to find these kinds of vulnerabilities, but like you said, we can use automation to find which changes our development team are making might introduce the vulnerabilities, to literally read the tickets and to say, this ticket seems like it is going to, or this ticket seems like it relates to something where business logic flaws might be. You are changing the checkout flow, you are changing the authentication flow. These kinds of things are a gold mine for a security tester to then be able to jump into and specifically focus on. It's also really, really great at being able to identify the changes that aren't going to introduce a business logic flaw, and to say, this change might introduce injection vulnerabilities, but you've got SAST and you've got DAST that are really capable of finding those kinds of vulnerabilities. So you don't need to look at this, which is obviously, it's important, because like, we've got an engineering team of 5. We're only a startup. But we do not have the capacity, even with two relatively, two seasoned security testers. We don't have the capacity to test all of our own changes ourselves. Our developers raise 3 or 4 pull requests a day. Each of those pull requests, if we were to raise them all, test them all manually every day, would take us several hours. But instead, because we've got this LLM effectively operating like a pen tester's nose, sniffing out the changes that are relevant to us and parking the changes that we know have been tested adequately through the other controls and the other gates we've got, that means that we only need to spend a few hours a day, or in some instances a few hours a week, actually doing manual testing. And it also means that we can test every change, right? It means that when we do push something to production, we can say with a level of confidence that it has been fully tested for all of the vulnerabilities that might have been introduced by it, and that those vulnerabilities aren't there. Whether they took manual testing or automated testing is kind of irrelevant at that point. It's important we've got the manual testing when it's needed and the automated testing when it's needed. But fundamentally, what matters is that every change is being tested, and is always being tested for all of the vulnerabilities that are present, not just the ones that we can do using automation.
Yeah, and I think just before we jump on, I think if we think about sort of traditional testing and sort of some of the, I'm sure you've had the same experience that, I've had, or at least a similar one, where you're given a scope of an engagement. You're told, this is the applications, this is the API or network infrastructure that you're going to go away and test. You've got X amount of days to go away and do it. And you're sort of given, documentation on that thing. You might be given design documentation, you might be given high-level technical documentation, whatever else, you might be given by an account manager or some other person within that organization. And sort of your next task is to go away and, a lot of the time you'll have to ask the developers themselves, say, what's actually changed recently within the application? When was it last tested? Is there any new features in here? And I think when we talk about sort of the problems with that, it's that from the get-go, when you're given a penetration test to do, you don't necessarily have all of the context that you've got. And LLMs in this case can be quite useful in providing you that summary, providing you that baseline sort of overview of, this is what has changed. And when you piece all of these changes together, you can start to build a picture up of, say, oh, well, when I go and do the test, I can actually, now I need to focus on this particular area, rather than just sort of confronting the entire application and thinking, well, now I need to do a checklist exercise, especially if you're on a more junior level, sort of following the checklist and say, I need to test for everything. And things seem to become a lot more rushed. Whereas, when you have that sort of helping hand, when you have that, as you said, the pen tester's nose to guide you sort of through that landscape, you can sort of pick up on things and say, okay, well, recently a developer has changed the authentication mechanism, so I'll focus, a lot on that. I'll focus on this point, I'll focus on that point. And you end up just sort of really spending a lot of time focusing, okay, this is what's changed. I can focus deeply on that. And also take into account what hasn't changed as well, because sometimes, I think especially sometimes I find anyway, that some of the more neglected areas of the applications that we test are actually some of the more vulnerable, because sometimes people forget about about features they've had there for a long time, and they don't update them, they don't keep them, in line with the best practices. So yeah, I think it's definitely something found useful for us.
So going back to the case study then, going back to what I said about in the beginning, let's talk about a specific example of how traditional gates failed us and how LLMs came to our aid in a vulnerability. I mean, you found the vulnerability. Do you want to walk us through the actual issue itself, and then maybe I'll touch on the failures in process that led to it?
Yeah, sure. So to sort of kind of set the scene, we recently we've been working on refactoring our permission system, and the developer who had been assigned to take on that ticket and do that job had pushed some changes into our staging environment. And essentially the crux of the feature was to allow administrative users, so sort of customers that would be on our application with administrator access for their organization. The new feature would allow them to toggle the role permissions associated with other users within their organization. And the code that had been implemented and pushed to staging essentially meant that there was a privilege escalation problem, because any user, regardless of their role, could modify the permissions associated with their account and actually enumerate the privileges of all of the users within the software, and then select whichever one they want, which would be essentially the top level one, the super administrative role, and then assume that, and they would essentially have complete control over the application. So it was quite an alarming, vulnerability, something that we were, really happy that we've actually managed to detect. And the way that we detected it, or the initial way that we sort of picked up on it, was that within all of the changes that had been made as part of that cycle, that latest sprint, we had been trying to think of a way that we could sort of prioritize them into an order of which ones need security testing at the top level, which ones need security testing at the bottom level. Because, like I said, there's lots of changes that come through day by day. It's difficult to keep on top and test them in that way. So we sort of asked we used a large language model. We provided it with some prompts, and we put together sort of this kind of personality type thing. We said, you are playing the role of a security engineer. You have been tasked with assigning or sort of analyzing tickets and pull requests and determining whether security testing is required, including putting together a testing plan and sort of what priority up the list would you put this test up in terms of all the testing we had to do. Where would you put it? Would you put it at the top as the most priority, or the bottom as the least priority? And the results came out, and we had a list that we could go through, and it was right at the top, the first one which we had to look at, and it sort of gave a very high level description of what's changed. It said the permission system has been modified, the user privilege has been given extra permissions to allow it to modify the permissions associated with other accounts. And so we went away and tested it. Just before I go on to that, it sort of had an overview of what type of vulnerabilities could have been introduced. So the number one thing was privilege escalation, authorization bypass, and authentication issues, because as part of that change, there were quite a number of things. And so when we went away and tested it, we found that vulnerability, it actually existed. We could perform privilege escalation. We found that it was quite a trivial exploit. We could quite easily just abuse it to privilege escalate up the tree. So yeah, that's kind of a very brief overview of how we sort of managed to use an LLM to capture it. But is there any other points that you want to add on to that?
Yeah, I mean, I think it's worth just addressing, as I say, there are control failures in the process that led to the vulnerability coming in the first place. So first and foremost, we've got a great development team. Now, have we frozen? Oh, no, I think we're okay. We've got a great development team. I'm a little bit biased, but we do. Particularly, and I'm not going to name a name, but we've got a great developer who's really, really capable of.
And he's
he's just capable of smashing out tickets like you haven't seen. The problem with that is keeping up with the rate of his development. So I am wearing my sort of product manager hat, writing tickets based on requirements that we have from various different customers. But this developer is closing those tickets faster than I can write them. So the tickets are getting shorter and shorter and briefer to the point where we had a requirement to be able to provide users with or customers with the ability to manage permissions of their users. I simply said in the ticket something like allow users to manage administrative privileges. I didn't explicitly state don't allow them to manage super administrative privileges. I just said allow users to manage administrative privileges. So that's what happened. He didn't fundamentally have the depth of knowledge about the permission system. It wasn't an area that they'd touched before, and I didn't have the sort of foresight to be able to say that is an area that, you know, that these are the specific privileges, because I'm not a developer. These are like, so I didn't know the naming convention exactly to say these are the specific privileges that you need to be able to consider and the ones that you need to be able to avoid. So he did exactly what the ticket said, carried it out. There were no issues with libraries, so it completely passed the SCA. There was no issues with the formatting, so it passed linting. There was no issues with things like injection flaws, so it passed SAST. And it passed DAST as well, right? There was no, fundamentally, the application was behaving in the way that he'd intended to develop it to behave in, and had that user have been a super administrator, they absolutely should have had that entitlement. So DAST or SAST wasn't going to flag it as a flaw, it was an intended feature, quote unquote. It was only by passing it through a language model that was able to highlight, actually, you're touching a permission system, this is likely to introduce, or this has the potential to introduce a privilege escalation vulnerability. And by the way, privilege escalation vulnerabilities can't be found by these tools. That instigated us saying, okay, let's kick off some testing, let's get Rich to step in, actually look specifically for privilege escalation vulnerabilities, and specifically in this area of the system, that led to us actually finding that vulnerability. And that's fundamentally what happened, right? Lots and lots of control failures. Thankfully, that one final control, the only one that we had in the system that was capable of finding these kinds of vulnerabilities, did its job and resulted in us finding that. I'm getting the signal, by the way, that we're coming close to the end of time. I'm conscious that we did say that there'd be a few Q&A questions, so just checking to see if there are any of those at the moment. I have no idea how to use this system. In fact, while Serena brings that up on screen for me, it's probably worth mentioning that, you know, look, this is very much an experimental thing for us, these webinars. This is the first one that you've all had the opportunity to do. So maybe, you know, there's a little bit more fluidity that we'll be able to develop. But most importantly, what we need from your end, our viewership, is your perspective on what you'd like to see next. You know, we're happy to put on talks about various different things, ideally related to security testing, and go from there. But effectively, let us know what you'd like to see. Here they are. So, Claire says, how do you avoid false positives and hallucinations? That's a good question. Yeah, everybody's got a phobia of false positives and hallucinations when it comes to language models. There's a couple of things in there, right? The first thing is that we're not directly asking the model to be able to write out, it's not synthesizing a large amount of data. Effectively, all that the model is responsible for doing is interpreting tickets and pull requests and other pieces of natural language written by developers, and then tying those in against a discrete set of different classes of changes that are already defined. There's only so many different ways you can change a system, and effectively by providing it with the ability, well, first and foremost, to decide whether a test is worth doing, and then afterwards to decide what specific type of change it is from a list, we can say with a relative level of confidence. But it's not infallible. It does produce a level of confidence that it declares in its own output, and if it falls below that threshold because the ticket wasn't of high enough quality, or because we didn't we didn't have enough information in our definition of classes to be able to tie it to the right thing, then that gets flagged for a person to be able to look at it. But those, instead of having to process thousands of tickets every day with a pen tester looking at them and saying this one's this and this one's this, we can actually get it down to, you know, a handful, a few dozen at most. What else have we got? So how do you, did you do anything special with the LLM to take into account your own knowledge base? Yeah, I mean, I guess, do you want to take that?
Yeah, sure. I mean, you know, we have a sort of collection of our own vulnerabilities and our own descriptions of changes that typically occur across, you know, that you might see in applications anyway. I think from more of the model perspective, what we sort of found is that depending on the types of model you use, there are actually ways that you can structure prompts to get better results out of them. You know, a lot of models are trained in different ways on different data sets, and you know, in particular, for example, you know, the ones which we've used have been trained using data structured in XML tags. So it's actually quite interesting, because if you start to structure your sort of prompts to these language models in ways that sort of account for the way they've been trained, it can actually improve the outcome of the model. And I think just going a bit deeper on that as well, we also provide examples within those of things that we would classify as a change. So it's not exactly going in completely blind. We do few shot classification, which would be sort of taken into account. This is an example of a testable change. This is an example of a non-testable change. This is some, you know, examples of some vulnerabilities that can come out of this change and that change. And the more examples you provide, sort of the better the quality in terms of the results that you get back. So, and that's sort of built from our own experience as we've been going forward. So, you know, when we've actually been looking at changes ourselves, because obviously, you know, through this entire process, and like we say, it's largely experimental, we are looking at the changes ourselves and determining, does this require security testing? What kinds of vulnerabilities could be introduced? So that's sort of, in a way, it's sort of a supervised process where we're sort of helping the model come to the decision by providing it with sort of already labeled data. So yeah, I mean, that's massively helped improve the outcome of the results. So.
Yeah, there's a very unsexy side to the platform that you don't get to see in the general product demos, where there's an interface where all of these events that we're receiving from customers go into that. And as confidence has built over time, we've been able to hand over more of the responsibility to the model. But we still have to go in on occasion and say, you know, if the data looks like this, map it to that, and build up this this database of pre-training data that we can then use to be able to build on what the model is doing in the future and effectively hand it over. At the moment, it works in a hybrid between us having some trust in it to be able to do some things and sort of more of a co-pilot, so that we're not having to write out all of these changes every single time, and we're not having to find them from a list of 500 every single time. But hopefully we can move much more towards a trusted approach where it can take the wheel and be passing all of these without any intervention, without any oversight. We are thankful in that what is happening at the moment is that people aren't processing every single one of these changes and every single one of these tickets. So I think people give us a little bit of grace in being able to do that. But the model's definitely, I mean, you'd be amazed what the model's able to do even without any of the pre-training. So yeah, I think we're in a fortunate position that this is only going to get better over time. Are there any other questions? I'm just conscious of time. Cool. Looks like we're all set. So the final thing, our next webinar is a live product demo. So if you want to see not just how we found the vulnerability, but how the rest of the system actually works, how we go from a ticket or a pull request to a series of testing actions, how those actions get delivered, and what the results of those actions look like, so you can get a little bit of a better understanding for what it is that we've been up to for the last few years. Come along to that. It's on the 15th of August, 2 p.m. I'd love to see you all there, but for now I will leave it there. So thanks for coming and great to speak to you all.
Yep, thanks for coming, guys. See you in the next one.